Why do we age? Scientific arguments about the nature of biological aging have now continued for more than 150 years and are still unresolved. There are three main classes of aging theory. Theories to the effect that aging is the result of fundamental limitations, modern programmed aging theories, and modern non-programmed aging theories. As we will see, each class of theory logically follows from a particular concept regarding the evolution process. Aging theories are critical to medical research on highly age-related diseases like cancer, heart disease, and stroke that are now responsible for the majority of deaths and health costs in developed countries. Any scientific aging theory must explain how aging relates to the evolution process and also explain the many observations concerning aging and lifespan. When we speak of lifespan or aging, we are referring to internal limitations on how long an animal will live, as opposed to external limitations on wild populations such as predators, infectious diseases, or food supply. Of course, evolution and the evolved characteristics of current species occurred under wild conditions. As we all learn in high school, Darwin's theory says that the evolution process causes organisms to acquire traits that help them live longer and reproduce more. This idea explains why we have ears, eyes, fingers, toes, and the vast majority of our other inherited characteristics, all of which help with survival and reproduction. However, deterioration and death due to aging did not fit Darwin's ideas. Why aren't we immortal? Why didn't the evolution process eliminate aging just as it acted against myriad other adverse factors like predators and hostile environments? This conundrum eventually led to three slightly different versions of Darwin's survival of the fittest idea. An obvious solution to Darwin's dilemma is that immortality or even a longer lifespan is impossible because of some law of physics or chemistry that can't be overcome by the evolution process. There are, of course, literally books full of laws of physics and chemistry. Because this idea matches Darwin's theory as generally taught, and also matches our common experiences with aging in automobiles, exterior paint, and other non-living systems, it is still popular with the science-oriented general public. However, there was a major problem. In more than 100 years, theorists were unable to explain the huge. Two observations were central to the subsequent developments. Lifespans of biochemically very similar species were observed to be very different. Mammal lifespans vary over a range of more than 200 to 1. Fish lifespans vary over a range of more than 1,300 to 1, from weeks to centuries. Symptoms of aging, on the other hand, were very similar between mammal species. If aging resulted from fundamental limitations that affected all species, then why were lifespans so different, even among very similar species like mammals? Why would a law of physics or chemistry affect dog meat different from, say, elephant meat? This eventually led to two modifications to Darwin's ideas and two sets of dependent theories. In 1952, Peter Medawar, a subsequently Nobel Prize-winning biologist, suggested that the evolution process must incorporate some relationship between internal and external causes of deterioration and death under wild conditions. This resulted in 2 points that are now widely agreed. First, the evolution process would strongly oppose any trait that resulted in deterioration or death prior to the age at which a species could complete a first reproduction. Everybody agrees that a species that died of old age prior to puberty would become extinct. Second, the evolution process would not oppose a trait that caused deterioration or death beyond the age at which all of the members of a wild population would be dead anyway from external causes. Imagine if 1,000 immortal wild mice were born today. How many would still be alive in 3 years? Because of external causes, probably none of them. Therefore, mice would not benefit from having the internal capability for living longer and would not have evolved the capability for living longer. Medawar thought that aging had no negative effect on a wild species. However, subsequently, George Williams in 1957 suggested that age-related deterioration in survival or reproductive characteristics of humans and other mammals occurred at too young an age to have no negative effect even on a wild population, despite Medawar's declining value of life idea. He therefore suggested that aging must somehow convey a compensating evolutionary benefit that offsets the residual decline disadvantage of aging. These ideas that the evolution value of continued life declines with age following first reproduction, and that aging must convey some evolution advantage, are central to modern non-programmed and programmed aging theories. Medawar and Williams are widely thought to be the fathers of modern gerontology. Modern non-programmed theories are based on the idea that indeed there exist natural deteriorative processes that cause various gradually increasing symptoms of aging. Living organisms possess many maintenance and repair mechanisms that can oppose the deterioration, but only to the extent needed by a particular species, according to the preceding evolutionary concepts. These theories provide a much better fit to the lifespan observations, but fail to explain some other observations to be described. Because different conditions and diseases have different causes, the associated repair mechanisms must also be different. This leads to the idea that there is no potentially alterable factor that is common to many symptoms of aging. Therefore, anti-aging medicine, or a medical approach that simultaneously treats or delays many symptoms of aging, is impossible. Here are some specific non-programmed theories that suggest aging is an unavoidable side effect of some beneficial property. That is, aging is linked to the beneficial property. Since the evolution process is obviously generally able to sort out and separate beneficial properties from adverse properties, such theories need to specify why such linkage would exist in any particular case. Williams' idea supposes that a specific genomic property called pleiotropy causes the linkage. Kirkwood proposed one of the many theories suggesting aging is a side effect of qualities that increase reproductive capability in youth. Many gerontologists did and still do consider that the foregoing theories provide a good explanation for mammal aging. However, in another corner of the theoretical science universe, other theorists were wrestling with other apparent discrepancies between Darwin's theory and observations. Darwin's theory says that any animal should defend itself, its mate, and direct descendants, but is in competition with other members of its own species. This is the red of tooth and claw aspect of Darwinian evolution theory. Of course, human societies have endless laws, social behaviors, and even religious commandments that constrain individual behaviors in favor of a population. This was widely seen as, quote, the difference between humans and animals, unquote. However, eventually animals were observed to display just such altruistic behaviors that did not make any sense in a Darwinian context, such as being observed defending an unrelated animal. Eventually, other conflicts with Darwinism appeared as shown here. This led to a whole family of population benefit theories beginning in 1962. The population benefit theory suggests that a long-term or population benefit can offset some degree of short-term or individual disadvantage and result in the existence of a somewhat individually adverse trait like aging. It's obvious from the proliferation of theories that our collective certainty that we really understand the mechanics of evolution has declined since about 1950. Darwin's evolutionary mechanics, as taught by Darwin, suggests that an individual disadvantage would always override a long-term advantage. However, recent genetics discoveries support recent theories, allowing population benefit, and all of the apparent discrepancies mentioned earlier have population benefit explanations. Various theorists have now suggested at least a dozen ways that a purposely limited lifespan could provide a population benefit, and that therefore organisms generally possess an aging program or suicide mechanism that provides that function by causing the many symptoms of aging. Like other biological programs, the aging program presumably would involve elements such as a biological clock that would determine when aging should occur in a particular species, and hormone signaling to control senescence in various tissues. Because the program and its components are common to the many symptoms of aging, we can devise pharmaceutical agents that generally delay aging by interfering with the program, by slowing the clock, or interfering with signaling. Therefore, anti-aging medicine is possible. Substantial evidence to be described supports programmed aging theories. Darwin assumed that the ability to evolve was a fundamental property of all living things, essentially a constant. However, it is now clear that organisms can possess traits that affect their ability to evolve and adapt. Genetics discoveries have contributed to this issue, which is an important part of any modern discussion about evolution. Here's a summary of different ways in which a limited lifespan could produce a population benefit. For generations, the gerontology community largely rejected programmed aging and all of the supporting population benefit theories as, quote, theoretically impossible, unquote, according to the traditional Darwin mechanics, and therefore contrary evidence was discounted. Recently, such theoretical objections have been waning, and it's apparent that experimental and observational evidence should have priority in determining the nature of aging. In this section, we'll discuss various items of empirical evidence that support programmed aging. Species that apparently do not age are a problem for non-programmed theories because they need to explain why such a species had an evolutionary need for an extremely long life, not needed by similar species, and therefore evolved and retained such a long life. Program theory suggests that the organism had a suicide mechanism initially, but it was disabled by a mutational change. The species consequently has a long-term disadvantage because it doesn't age and might be expected to eventually become extinct without producing descendant species. Non-program theories suggest that any given species has evolved the ability it needs in many maintenance and repair functions associated with many different symptoms of aging. Therefore, there is no single mechanism responsible for aging, and there should be no single mutational change that would simultaneously affect many diverse symptoms. Program theory suggests that lifespan is a compromise between the short-term need for survival in order to maintain a population and the long-term need to evolve or otherwise avoid extinction, which is benefited by a shorter lifespan. In the case of famine or other temporary condition that increases mortality, it would make logical sense for an aging program to temporarily defer the long-term need and increase lifespan in order to meet the short-term need. This is a programmed aging explanation for caloric restriction. Stress effects have a similar explanation. If a mammal population was under heavy predation, individuals would no doubt experience stress in the form of sheer terror, very intense physical effort, and other effects that a programmed aging mechanism could detect. Here again, it would make logical sense for an aging program to temporarily defer the long-term benefits of aging by increasing lifespan. This fits with stress observations. Genes that cause aging are probably the most persuasive evidence of programmed aging. Other associated elements of aging programs, such as signaling and sensing of internal and external conditions, have also been discovered. Octopus suicide is not only obviously programmed, but also obviously incorporates programmed elements previously mentioned, such as a clock, signaling, and sensing. The non-programmed argument is that the octopus has some so far unidentified need for suicide, not possessed by gradually aging mammals, including humans. Here is a summary of some agents and protocols suspected of having anti-aging properties. The NIH Interventions Testing Program tests proposed anti-aging agents in mice. Each agent is redundantly tested at 3 different laboratories. Initial results suggest rapamycin has significant anti-aging properties. The 3 aging theory classes have very different implications regarding the nature of mammal aging and therefore the nature of human age-related diseases. Non-programmed theory suggests that the wide variety of different aging symptoms is caused by a large number of functionally independent factors, and that therefore each symptom must be separately addressed by medical researchers who are looking for damage mechanisms associated with each symptom and ways to repair or prevent the disease-specific damage. Programmed aging theories suggest, in addition, the existence of a common aging program that causes or allows multiple symptoms of aging. Tissue-level aging is coordinated by signaling. Researchers following this path are looking for signals, clock mechanisms, sensing mechanisms, and ways to interfere with these elements in such a way as to generally delay aging or ameliorate aging symptoms. Notice that this approach can be applied in parallel with and in addition to the traditional medical approach. Because this is a new approach, if it's valid, we could expect to see rapid progress, at least initially. Lack of scientific agreement regarding even the nature of aging tends to discourage investments in age-related disease research. Worse yet, widely believed traditional evolution theory and associated fundamental limitation theories, as well as many non-program theories, tend to suggest that aging, per se, is an untreatable condition, and that therefore there is a theoretical limit to the extent that we can treat or prevent highly age-related diseases. Are we near this limit? If so, further investment in age-related disease research could be expected to be increasingly futile. Research specifically directed at definitively solving the programmed-non-programmed issues should therefore be a priority. Scientific opposition to the evolutionary basis of programmed aging is declining. Senior members of the non-programmed aging school have essentially conceded that population benefit can influence the evolution process and no longer oppose specific proposed evolutionary mechanics suggested by programmed aging theories. Recent developments suggest that programmed aging concepts are the subject of rapidly increasing funding. The Google AbbVie investment is certainly the largest ever to be applied to programmed aging research. Other pharmaceutical and medical research organizations cannot afford to ignore this development, so additional substantial investment in programmed aging is likely. The existence of the American Academy of Anti-Aging Medicine suggests rapidly increasing acceptance of the idea that aging, per se, is a treatable condition. The developments we've been discussing are exciting and suggest that a substantially different approach could greatly expand our ability to treat and prevent age-related diseases. The latest version of this presentation and many supporting documents can be found at www.azinet.com/aging. Thank you for visiting this presentation.